So I just set that. Okay, so I'll share my screen. We'll make a start. If there's any questions you have or you need to translate, then just stop me. It's okay. Otherwise, I'll carry on. I'll try to go slowly, but if I'm going too fast, also tell me to slow down. Okay, so the new Sylvac S25T. This has been introduced to complete our range of scan machines. This is now the smallest one we have. So we have the mid-size F60, we have the large 145, and now with the Sylvac S25T, we have a nice small system for the smaller parts, the micro parts, which opens up the door to other markets that we perhaps did not have before with the bigger machines. And of course, this has some new innovative design features, which I'd like to discuss with you today. So the principle itself, in terms of how the machine works, is the same as the other machines in our range. So we have the illuminator on one side of the machine, or which is a collimated light, a parallel light source, which we project across the part. This generates a shadow through by telecentric lenses, and this shadow or silhouette is measured using the line scan camera. So this is the same technology across our machines. However, of course, for this small machine, we have changed a little bit. So we've got a higher resolution system and a higher optical system there as well to give us a better definition and higher accuracy on small micro parts. The technology is, let's say, similar across our competitors in terms of what we do. We're using the illuminator and the telecentric lenses, as is bi-telecentric, and we also use a CMOS line scan camera. Some machines in the market use a CCD camera, and some machines have a completely different take and they have a matrix camera, but I'll explain about that when we get on the competition. Okay, if you need to ask any questions, please feel free to jump in. I'll take you through. No questions so far, okay. Good, thank you. So I'll take you through some highlights. So as you mentioned, this high resolution, high definition system, less than 1 micron diameter accuracy, less than 3 micron length accuracy. We have moving optics on this machine. So the optics are moving up and down on the machine, like the 145, different to the F60. But on this machine, we also tilt the optics. So we tilt the optics up to 30 degrees, and this allows us obviously to measure the threads, comprehensive thread measurements, and I'll talk more about that later in the presentation, because this is an important point. It's a very, very strong sales point we have, is this tilt axis for thread measurement. Scan speed, 50 millimeter per second, moving up to 100 millimeter per second. So nice and fast. Typically, a part on here will take 3 to 4 seconds to scan completely. We have a high resolution rotary axis, 0.0003 of a degree resolution. It's a nice compact design. So a desktop sort of size. Okay, it weighs around 70 kilos. So it's portable-ish if you want to lift it around, put it in the back of a car, take it to a customer, move around the showroom, move to exhibitions, etc. So it's portable, much more portable than the other systems, of course. It has the same easy-to-use software that the F60 and the 145 has, so what we call Reflex Scan Plus. So really easy to use, but powerful, and can measure all the complicated features you need to measure. We've also introduced the new Touchpad, okay, which you'll see, and I'll take you through on the video with the machine shortly. And this is a new interface we've introduced on this machine model, and it allows the operator to use the machine, run the machine in terms of selecting programs, measuring the programs, and reviewing the results summary only by the touch panel without having to interact on the PC itself. The PC is still supplied as standard, and the main application software is still how you control the programming side of things, but the touchpad on the front is there for an additional ease of use software panel there for the operator to use on the shop floor. We have a new custom thread wizard software. This allows us to measure custom threads, and I'll talk about the software as we go along, but it's released with this machine because this is one of the target sectors. It's things like bone screws and dental implants. The machine, importantly, is automation ready. So this means out of the box, delivered to the customer. If the customer wants to automate it straight away, or they want to automate it in 2 or 3 years' time, this machine is ready for that process to be done. That includes the motorized tailstock. Okay, so the tailstock is this portion here, the yellow, which moves up and down. This allows us to clamp the parts if we're clamping between centers or different fixtures, and allows us to position and clamp that for the robot loading, so the robots can come along, place the part in the machine, and then the machine will actually automatically clamp for you. So we have additional I/O connectivity on the back of the machine, which allows us to connect hardwired into robot, machine tool feedback, PLC, this type of thing, and also pneumatic preparation on the machine. So this allows us to connect standalone fixtures in there, such as grippers and chucks, allowed to be controlled as well through the software. So that's an important point. Again, this is a real strong point over the competition. We're the only one that deliver machines automation ready today. So that goes in hand with the rest of the Sylvac concept in terms of IoT Industry 4 revolution. Part of that and part of the ergonomics to have an easy to use machine is we have quick release tooling. So there's no need to pull levers and screw things out or use tooling to extract it. So quick release tooling, which the robot can also grab itself. It's designed for the shop floor. Of course, it can be used in inspection environments as well, with an integrated calibration master, which keeps the control of the machine throughout the day, with temperature sensors on the machine, measuring the environmental temperature, and this will actually trigger the machine to go and calibrate and keep in a controlled performance throughout the day, regardless of the environmental temperature. We have new LED status lights on the side, which we'll actually see in this white blue color here, to illuminate the part itself, so when we can see in the machine to actually load the component, but they're there as well as classification, so pass, fail, warning, etc. when the part has been measured. Okay, and we're obviously teeing up to have specialized parts there. So I'll go through a couple of more slides, and then perhaps I'll pause for some questions. So applications, of course, anything cylindrical which fits on the machine envelope, that's what we're looking for really. It doesn't have to be in a certain sector, but these are some examples of the ones you could explore with this machine now with a higher definition. So obviously watch parts being Swiss, we have lots of watch manufacturers, so we're keen to have a solution there for small pinions or fixtures or parts that might be in the watch itself. And then we talk about dental implants. So here they are very small. They have custom threads, so they're non-standard threads, and small intricate features which need to be measured, similar to bone screws, of course. And these dental implants and bone screws is really where our tilt system comes into play and allows us to measure those features other competitors cannot do successfully. Instruments, medical instruments, general parts, general term parts, electrical. So when we talk about electrical, we're talking about the connectors themselves and also the small pins inside. So there are millions and millions of these made everywhere around the world. And of course, these small pins fit into something because they need to be manufactured to a tolerance as well. So these are a good opportunity to go on there. And we recently sold a machine to TE Connectivity, which is a global player, a global company manufacturing these small component parts, which may be in a car, it may be in the back of a television, it may be in an aeroplane. For example, lots of connector applications out there. And we talk about aerospace fasteners or any fasteners in general, really, but aerospace fasteners are obviously critical and they're a bit more specialized, and we have a nice solution for these types of parts. And then we talk about automotive. It could be small engine parts, it could be fixturing components, it could be motors for the electrical cars. So nice industry still to have in sight.
Do you know the Taiwanese market? Or?
Pardon, say that again?
Do you know the Taiwanese industry market?
Probably not as much as I should do. Was there a comment you should perhaps share? Perhaps you can share something.
Yeah, according to my experience, it's very similar to Switzerland, actually. When you visit Taiwan, you will find a lot of small turning companies, small company with 2, 3, 5, 10 guys making turning parts, really similar to the company we can find in the Jura or around Malray, you know, all this kind of company producing turning. Fastener is also a big market in Taiwan. So I really believe we have a promising market in Taiwan for this small machine. According to what I have seen the last 15 years when I was visiting Taiwan with Everbright, I really believe there is plenty of opportunity in Taiwan.
Perfect. That's what I like to hear. I knew there was some, obviously the micro, I know a little bit the watches, there was electrical, a lot of electrical stuff as well, or so?
Watches, not really, but general alternate parts, fastener connectors, definitely, yes, a lot.
Good, nice to hear. So no excuses then, we see lots of orders coming. Some points here, but we'll look on the machine, but just in a presentation format. So you can see the touch panel, top right-hand corner. We have the motorized tailstock. So this is just to point out, it's yellow on the machine, but in reality, it will be black for customer machines. I just happen to have a yellow one of mine because we were testing the colors. Moving optics, so you don't actually see the optics moving very well, let's say, because they're hidden to be protected. So they're behind the covers, but I'll try to show you that when we look on the machine. As I said, they tilt as well for the thread. LED status bars down the side, quick release tooling, you'll see. Pneumatic preparation. And inside this cover underneath here, in fact, is where the master is used to calibrate the machine as well. So we'll look at the specifications of the machine. So we're really measuring from 0 upwards. We say 20 microns in terms of the size of parts. There is a limitation, but in reality, no one's going to give you a part that small. And up to 26 millimeters diameter, 200 millimeters in length, measuring capacity. We can hold up to 51 millimeters diameter. So if you have a part which maybe has a big flange on there, you can still measure the rest of the component because you can hold it on the machine. So our release accuracy here, we are saying 1 micron diameter, 3 micron length. However, the target, which we will move shortly to, is 0.9 on diameter accuracy, which is incredibly accurate and will put us ahead of the competition on the market. And we'll look at that further in the presentation. 2.5 micron length accuracy, repeatability 0.4 and 0.8 there as well. So really accurate machine, really impressive in terms of what we can measure and small features. And the experience we've had on the first few machines is really, really impressive. Tilt up to 30 degrees. Measurement speed we discussed. Rotation speed is 1 rev per second. That may increase in future, but at the moment we're 1 rev, 3 kilogram weight per capacity. Dimensions I'll skip over. Delivery at the moment, we are looking more or less 12 weeks. If you ordered a machine today, by the time you see it at the customer, it will be around 12 weeks. This is due to a first initial production phase. We have to speed, let's say, ramp up production, but also we have the backlog of orders for demo machines and customer machines as well. So eventually, during the year, this will decrease down and we will be less than 4 weeks delivery time, the same as our other machines. So around mid-year, we should reach this point.
Okay, you understand? Hello?
It's clear?
Yeah. Thank you. With the Chinese traditional version, so we can understand Johan what he said.
Okay, I'll continue.
Please.
Okay, good. So with the standard delivery of the machine, we have to consider what we, of course, receive at the customer. So we have, of course, the machine according to the specification. We have a standard Dell mini desktop PC with Windows 10 multilingual software. It also comes with a keyboard and mouse, of course, and the 24-inch touchscreen, which is nice. Then we have some accessories we include with the machine. So we have the standard ISO adapters, 2 of those. We have the standard centers, 2 of those, and we have one what we call live rotating center. So this is the one you'll see at the top of the machine with a bearing on. And then we have a drive center at the bottom, which sits in the rotary axis, which enables us to rotate round. So that has a coating on to give a friction. Operating manuals, etc., are all available. I think we actually deliver the printed ones of the machine at the moment still, but that may, or maybe a QR code link to the website to download those. Okay, so there's your standard delivery. That will be in the catalog when we've updated it, so you'll see all that information anyway. Dimensions of the machine or overlook of the machine, you can see there the ones it talks about. Okay, nice and compact, so we can move it around, place it on a desktop, no problem, or a higher position, small stand. The machine comes with handles, which you can obviously take off there, but they can be used to move the machine around. When you receive a machine, you'll see it will arrive in one crate, a standard sort of crate size you've probably seen from Sylvac there. And as soon as you lift the sleeve off the top of the crate, you'll see this image on the bottom left-hand corner with the machine bolted to the pallet in the middle. And then you'll have the accessories like the PC and the screen on either side of there. You need to remove two side panels of the machine itself, and that will reveal the bolts. So there is 2 screw bolts through the machine into the pallet. So you just need to remove these. You can lift the machine off the pallet then. Once you position the machine into the sort of final position where you want to use the machine, you then need to remove this red clamp, which you'll find in the back of the machine just behind the optics there. There's 4 screws on there, and that's used to clamp the optical head during transportation, of course. So it's a fairly quick process to have that removed. When you receive your service training, they'll detail this a little bit more anyway, so we can go through those steps in the service training and talk about how to connect the machine up and what connections you've got, but it's fairly self-explanatory. And of course, it's in the manual as well.
So for the service training, it will be after you have received the machine, because it gives no sense to arrange the service training before you physically have the machine in Taiwan. So we will reschedule the service training for after you have received the machine. Okay?
Okay. We'll come back to that point if needed them. So a few more specification details that we don't necessarily show in brochures and things, but maybe of interest to you. So we've talked about the measuring speed. Also, we have the encoder. Obviously, we use a run assure encoder on the machine, which is nice and easy to service. And it has a nice, good resolution of 0.05 microns there. We're subpixeling down to 0.1 of a micron. The panel on the front here is IP65, so it's robust to use on the shop floor. There is a tailstock force, clamping force of 1 to 12 newtons, and the tailstock itself can move up to 50 millimeters per second. And just a comparison when we talk about the definition to this on this machine, so versus the F60. The one on the left is the F60 scanning the same part as here on both machines, and the one on the right hand side you see there, the Scan 25 there with a higher definition. So you can see how it's increased and gives us a lot more information on small micro parts where it's required. We'll talk about the touch panel itself, and I will show you on this on the video. We'll go through this a little bit more as well. So we have the sort of main welcome screen where we can change modes between replay and reflex click. This has a big start button on there. We can open up a program and select via a menu by scrolling across and selecting that one. This is just a different variant of that screen with the load program. Once we've measured a part, we'll have a summary screen for the results where we get the global classification, the summary. You can print, you can scroll, you can replay the part. And then, of course, when the part is running, we can stop the machine if required. We operate the tailstock via the touch panel, so it's a full motorized tailstock. There's no manual operation on there other than the spring load on the spindle, which I'll show you. So we have a fast up to remove the part and move the tailstock to its top position. We can unclamp, which will just back the tailstock upwards. We have a directional move where we can use a slider bar here to move down or move up depending on the direction we move the slider. The further we move towards the end of that slider, it will then increase the speed. So you have a speed control in there as well. And then you have a clamp position, but again, I'll show you this on the video itself. We'll look inside a bit more sort of details. There's a cooling system on the back. So we have a push the air through. So we push air into the system to keep it cool, and we extract the air as well with filters on there, of course. That keeps the, let's say, the electronics in the back, which are heating up, things like motors, the camera, that type of thing, things that are moving, and keep that ambient temperature and keep it away from the metrology side of the machine, sorry. The machine has exit holes as well as vents at the top to allow the hot air to escape. Inside is a isolation system there, so it isolates the metrology away from the mechanics and the electronics of the system. On the front, you will find a pneumatic connection there, and I can show you this on the machine. That's there to connect the headstock with gripper systems, pneumatic gripper systems. If I take a cross section of the headstock there, you can see at the top it shows the ISO adapter, the ring, which we hold the fixed ring in, and then there is a calibration master actually, which is at the bottom of that there underneath the motor. So there's a little bit more detail if it's of interest. Now we talk about the software. Okay, so the software I should have changed the date. We just released it yesterday actually. You'll receive a communication soon enough. When you receive a machine for the Scan 25, it will have a new version of software. It's version 4.5. And this consists now of reflex scan. So we are rationalizing. So we're going to have two levels of software. We're going to have a standard one, which is delivered with the machine and includes all the measurement features you would expect to have, including a formula wizard. Then we'll have a pro version, which is an option. So it's a cost option. You'll find it in the price list. And this is something you can sell to the customer as an add-on. And this pro version of software includes Thread Custom Wizard, which I'll talk about shortly, allows you to program custom threads. It has scripting, so if you want to do anything custom or special for the customer there, maybe it's a completely new feature they want to write, you can do that using the scripting function. This also includes, Pro also includes the CAD import-export functionality, and also the new monitoring software. The monitoring software is the same as what you'll see in Silcom. So that gives us the SPC, the basic SPC information. So that's two levels of software. You've got a standard delivery, and then you've got a pro, which is an option. And the pro includes those features we include there. Offline software, you can have the standard offline, and it can also have the pro offline. So it mirrors the same levels of software, but the offline is, of course, when you want to make programs off the machine in an office environment or remote, complete remote away from the machine, for example.
Dwayne?
Yes.
Just a question about the release 4.5, but you wrote here by end of February.
Yeah, I also said I should have changed the date.
But it has been released or not yet?
Yesterday.
Okay.
Yes, yesterday officially internally, but we have to obviously share that with our agents. So normally we would release with a communication document. So we expect you'll receive this probably next week. That's my target at least.
Okay.
So I'm just out of dates on the presentation to when the reality happened, so I forgot to change this. So it's March.
Okay.
Okay.
And we will receive the information,
Yeah.
yeah?
Yeah, I need to just write the draft, and the usual process. Claude will send it out after. So
Okay.
yeah, you'll receive that information anyway, and the machine you will receive will have this version of software on. So it's not too critical at the moment that you have that information. Okay.
Okay, thanks. Yeah.
So inside the new version of software, obviously the new version has been also developed for running the new machine, of course, but we've added some nice enhancements, which are only going to help us sell the machine, of course. So we have what we call the Thread Wizard, and I'll take you through this on the machine. The Thread Wizard allows us to program custom threads. So historically, or on the standard software, if you have a standard ISO thread, you can just take a box measurement zone, you place it on the part where the thread is, and inside the algorithm will take care of the rest. It will detect where the different features are on that thread, like the flank angles and the root radius. However, when it's a custom thread and you have perhaps completely something non-standard like a bone screw, where you may have different shapes altogether. The standard algorithms couldn't detect where those features are because they're different. So to allow you to program that, we've added this wizard, and it can control the sub features. So it allows you to move the zones around, to position inside the templates where the flank angles, where the root radii are. So it allows you to create a template for custom threads, which you can recall and reuse over and over. So that's a nice facility, and I'll show you how we program that shortly. We're also now including in the pro level of software monitoring, the monitoring application. So monitoring gives you a basic SPC overview of data measured from measured parts. So it could be from 1 week ago, it could be from a few months ago, but it allows you to view the data collectively in one area. And you could, of course, get some basic statistics. You can have the evolution, you can have the run chart, etc. So you can see all the information on there with some basic values. If you're familiar with Silcom, it's exactly the same in Silcom as it is in the Sylvac scan machine. So that's the first step of introduction. Then later in the second half of the year, hopefully we'll see a web application to view this data remotely from all systems. So it could be pushed from the app, it could be pushed from Silcom, it could be pushed from the scan software, and it allows you to pull that information into one place and view that remotely via the cloud. And I'm sure Jean-Marie will update you on that as we move closer to the release. We've added some features in here called True Position. These are previously not available in the feature menu. So we've added a different menu basically to collectively put some measurements together that we had anyway. But True Position, as we know, is a requirement here, which will give you something similar to you see on the right side there, where we have a measured part feature where the green crosses is the target and the blue cross is the actual measured, and to relay that information as a measured value to the operator. So that allows you to introduce some datums in a 2D format, which we didn't have available before. Then we have a 3-dimensional or dynamic features of that, where we want to measure the eccentricity. Previously, this was found in the concentricity menu, but we've introduced a new True Position one. And then we have an additional feature in there called offset from axes, which allows us to take a position of a diameter relative to a datum, and also the angular position on there. But you'll see this in the software itself when you get your hands on the machine. So some new accessories we've introduced, and let me just do this. I think this part number is wrong. Okay, so we've introduced a new gripper. This is a gripper we've had, let's say historically something similar, but the cost was quite high. So we've re-engineered this, and we're making one in-house. And this gives us a 2-jaw V-gripper situation where we can grip from 0 to just under 20 millimeters diameter. So this is really ideal for holding small parts where you don't have center points in, or you can't use female centers. And this is available here. You have the chuck body, then you have to buy some jaws that go on the top, and this is available now. We have a 3-jaw chuck, so a smaller 3-jaw chuck we've introduced. A nice quick action on here for holding internal and external features. Then we have small V centers for holding parts, again, that don't have necessarily the center points in the end. So we have one which rotates live, so we have a bearing on it, which is the one at the top, and then we have one to drive the part round. And I'll show you some images of those being used. We have some further accessories coming. So sorry, just to comment, these are found in the price list, and you'll see them in the latest catalog when we release it in the next few weeks as well. So that'll be detailed. We have some other ones coming around the corner. So we have an internal version of the same gripper. So this allows us to hold the parts internally. So if you've got a small hole in the end of a part, for example, these small pins can go inside and grip. We have a pneumatic version of the 2-jaw gripper, a pneumatic version of the 3-jaw chuck coming as well. Then we have some small micro part pincers. So these will be dedicated to hold small components. As you see there on the illustration, it's a 0.5 millimeter diameter by 10 millimeter. So really, really small micro parts that we can grip with a lower grip force and hold the part, and then be able to see the part, more importantly, as well when we take the measurement. So that's interesting. There'll be a couple of 2 or 3 different options on there to have available. Then we'll have some new innovative accessories coming as well, which we're just going through the process of now, where we may even use magnetic fields to hold parts up and things like that. Lots of clever stuff coming around, so that'll be interesting to see. So give you an example of those parts being held. So you can see a small part, approximately 3 millimeters in diameter. It's been held there between the V centers, but they're turned on so we can see the end profile. The important bit is we can still see the end profile. Here's the 2-jaw gripper holding small bone screw. So you can see there how it's just held in a very small area there to allow us to visualize the rest of the component. A similar take there, but obviously this one's a dental implant rather than a bone screw. And then another example here of a dental burr. So really small micro parts held nicely in the fixture there, measured on the machine. Is there any questions on accessories or software options or specification of the machine before we move on?
Maybe we let them talk together for a few minutes to see if they want to talk together, translate some parts. Novia, Basaro, you want to discuss with your team for a few minutes?
没有，所以这个镜头可以摆30度。如果说这个他躲在光光先讲前，先看我问，
对，然后
有很快，那个就是地方，
那个就是那个单不单元是一样啊。
我讲天啊，只有开始。
他如果讲的话，看他讲这个他 PPT 上面接下来就是这个意思。尤其现在有机器之后，现在提不出任何，那我们就这么说。
看书面这些东西，我们现在有的时候然后问有的我就现在问，那没有的就让他讲完，然后再来东西交互。所以他
更新交给我，所以我现在不用更新的，他会重新他那个软件怎么给我？
哦，这软件要2月，他会给啊。
都说什么？一些改变，对啊，没那么快了。
一般的
3月底。
刚刚不好才会，但是
现在3月了。
我们当然要3月哇，那我然后就是对，那过来嘛。刚刚的解说来讲的话，就是应该可以看，不是应该这个他只有讲到这个，他有讲他的感觉不赖是比较离，他一般可能需要做连线才真正的变。那在机器它也可以做，那个什么，他手的机器正面的，机器端说你可能检测的可以先做，然后机器对的，这个我们到时候会给客户。
它是软体的到4前哦，优惠促销。恭喜我！
就要结束。
这个让他先想要抽机问他，现在一个个问，说不定他我会再写问他这些问，先听他讲。他现在也都不是没有。
刚还有这个在讲他的那个位置，对，是讲那个有这个位置东西吗？这种，你懂小学？
你说什么？
你不用懂。
小学你说的 position 是吧？
面包。 加油。
我们是量在这个位置。
量什么量着径啊？
是下上对的时候，还是对这个时候对有没有因为在上插上去的中
这个
跟后车的在同一个场景。哦，所以这
它这里讲一个feature is 特征样，他说是有经典的小路型，有中点正走的路，还有一个 hand between 5 minutes central， 这个就什么5毫米2点之间，
是那种有点类冰块的做。
你说这个夹具大家应该没，这就是那个一样的驾驶你先去做这个具一起加一个放上去，然后它住的那种，它配件。
你的问题是说是工件啊，是说比如说中心或者轴对称，
这是到时候它
好像有
对啊，介绍还有这些好加，然后我们可以出去。如果像那个的话，就要那个1.5说要量那叫轴，像车大刹车地，可能就要相比参照加工。
Hello?
Yes.
Okay, we can continue.
Yes. Thank
Okay.
you.
Okay. If you have any questions, obviously, you can type them on the chat as well. So I just want to explain the tilt system. It's an important part of the product and a very big strength we have over our competitors. So it's important we understand the principle behind it and what that offers to the customer. So the Scan 25 and the 60, so they both have tilt axes on the machine, and these basically mean the optics, they tilt or slew over to match the helix angle of the thread, and they go up to 30 degrees, and this allows us to project the image of the thread at the helix angle, which is the true image we are trying to view there. So I'll show you this on the presentation. This is an example of a bone screw. Okay, on the image you see on the screen, it's been scanned in without tilting the optics. If I rescan the same part with tilt, okay, so we've tilted the optics to 18 degrees. You can see the difference between the two profiles, and I can superimpose those over each other, and you can see the green line is the one we should be looking at versus the black line, which is the pre-tilt. And if I zoom in there, you can see the green line where it's tilted reveals the true radii and the true flank form. So this is really important on threaded parts. Without tilting, you don't see the true thread profile. And our competitors like to tell the customer that they can measure these features without having the tilt axis, when actually, in reality, it's not true when you get to especially threads with steeper helix angles. So on here, we reveal the truth profile, and it allows us to actually scan the data of that profile and give the accurate measurement of those profiles. There's no chance to calculate what that radius would look like by if you tilt it. There's no chance at all. So it's really a strength we have over our competitors, and it's really one it's important to understand. Of course, you have this in the presentation to refer back to. Is there any questions on the principle of the tilt?
就是说它比较我们真实的形状、那个缺陷、压可以。
Okay.
所以错。
Okay. So with the tilt system, it obviously opens the door to measure all types of threads, some of which I've put on the screen here. So you can see tapered threads, you can see standard V-form parallel threads, worm gears, ball screws, bone screws, dental implants, anything you like, different profiles we can measure. So we really don't have a limitation, providing it fits on the machine and we have the helix angle big enough, we are good to go. These are example features we measure on the threads. So the ones listed in bold are your common ones, your major, your minor diameter. So your minor diameter we only offer on the tilt machines. We do measure the major and effective diameter on the non-tilt machines. Okay, that's important to remember, but we only do it for V-form parallel threads and taper threads. When you have something else, you need to go to a tilt axis machine really. So we do the effective diameter, the pitch, the flank angles, and you can see all the root radius, crest radius, etc. There's lots of different features depending on the thread that we can offer. So we are in a really good position when we have threaded or screw profiles to measure. Okay, so we'll talk about the competition and see who's out there in the market, and we'll focus on 3 of those players. Okay, here's an overview of most of our competitors on the market. I'm not saying it's every one of them, but these are the ones we see on the market. So the ones on the top line, Vichy, Genoptic, and Mar, we consider those the 3 main competitors around the world. Of course, from different markets, it will vary. Okay, so from Europe to Asia to America, it does change slightly depending on the strength of the competitor in that area. Okay, but generally speaking, the top 3 we face are those 3 on the top of the presentation. I'll quickly give you a summary on the ones we see at the bottom, and then we'll go on and we'll focus more on the other 3 competitors there. So we have on the bottom left, we see Marpos. Marpos is an Italian brand manufacturer there. We do see them from time to time, but very, very, very rarely. A little bit more in Asia, maybe, I don't know. We see them from time to time more. I say time to time, I might see them twice in a year versus once in a year. And that's really how low we see them in comparison, but maybe you have a different take on this. So Marpos offer 2 types of machines. They have an OptoQuick, which is a traditional scanning machine, let's say similar to ours in terms of it scans the part and makes the measurements. They have a range, sort of mid-size and a bigger one, a small one. Not so nice to look at in terms of how they made. You really see all the workings inside. Ugly machine, software, not so nice. Performance on paper is so-so. It's middle of the road. I don't have pricing information on these because again we rarely face them, so it's difficult to get that information. It's not on the internet. So if you come across them, you do get some pricing. Please share it with us. They also have another machine called an Opto Flash, which is actually a 2D field of view system. So not quite the same approach as ours. And again, we don't see them on the market with this too much. We see them at exhibitions, but we don't see them in real life scenarios at all. We go across to Dr. Schneider. Dr. Schneider is a German brand, German manufacturer machine. These are complex machines, high price mark on these, difficult to use, but they do offer a lot of flexibility in terms of what they can measure. So these machines are really like a traditional vision system turned on its side to measure shafts. So they have a surface illumination, they have a moving optics to focus in and out into different areas rather than fixed and scanning in one axis. So that's a difference there. They have the probing options on there as well. And they have a big range of machines on there, but the price is very high. And we find them in really niche areas of the market where they find, you know, some competence that perhaps others can't do, and they really focus on there. So on a day-to-day basis, let's say we don't meet them at all, but on occasion we do come across them there. So we'll see on that one. Then we have OGP or QVI group. These are well known in the market for their vision systems. They're probably number 1 or number 2 everywhere in the world for their vision systems in terms of volume of sales and the variety they offer. They used to sell Vichy around the world. In fact, they used to sell the Vichy system, but this changed 2 or 3 years ago now. They parted their ways and they decided to make their own shaft measuring system called the Turn Check. So you can have a 60mm one of this or 100mm, and there is 2 or 3 different length variants. This is the only other manufacturer that have a tilt axis. They have a plus or minus 15 degree rather than a 30 degree tilt like us. So we have a more capacity than they do. I've seen this at exhibitions. I've seen it in the US. I've seen it in Japan as well. But in terms of facing them in competition, I've once or twice in the US, bearing in mind the US is our biggest market. Only seeing them once or twice is a good thing. And I've spoken to dealers and that sell the OGP, and they said they're not going to sell this machine because they're not confident in it. They don't have the specifications or the pricing and things like this. So a bit of a strange situation. It seems they're not ready really for markets. But I'm sure they will come over time. It's one to watch out for and to see what we can do for that. At the moment, I don't see them as a big threat, but perhaps they will come in the future on that one. The Oasis on the bottom right is really not apples for apples at all. But it is an entry-level system. It's a fixed field of view system to watch out for. You mainly see this in the US. I don't see them in Asia too often, but there's probably local, let's say, manufacturers doing this type of thing. Okay, that's a quick summary of let's say the lower players, and then I'll focus now on the 3 main ones we face. Okay, so we have Vichy, Genoptic, MAR. Now, the pricing I've got on here, of course, it's in euros. We use this as the baseline of the comparison. It's the Sylvac price list versus the competitors' price list, because that's what you have. Of course, this will vary in different markets, and the pricing will vary a little bit, but it's all relevant in terms of how we compare. So if you have pricing information in your market, then please, you can share that with us as well. So if I take a look at Vichy, on the far left side here, we have what they call the MTL X5 and X10. So this is their machine they position for the micro parts, the small parts on there. They go up to 8 or 16mm in diameter, 100mm in length. In terms of price, they're so-so. One is less expensive than ours. The other is more or less the same sort of price. The performance is lower. They are 2 and 5 micron, and I'll show you that shortly. So really, it's probably the weakest spot in the Vichy lineup. In fact, it's this product here, because the price is not as cheap as the others when you consider the whole range, and also the performance is lower than the others as well. So we're actually in a good position to fight this machine easily. They've introduced this other one, which is new. I don't have as much information on this, but this is what they call the X360. This is actually a mid-size machine, so not really like for like, but I've included it in the presentation so you're aware. And they're putting this in the X range, which means it's a higher definition system. And the price is 50,000 euros. On that, I actually heard it was 50,000 euros last week. So we're looking out for that one. But again, that's a mid-range machine, so we're really facing that on the F60 rather than the S25. Then the third one along the dark grey front on there, dark grey and white front, that's the Techno range. So this is their higher end range level. But again, on performance, we beat them from Sylvac, so we're in a much better position in terms of accuracy, performance, the software functionality, lots of different things we can offer above and beyond what Vichy can. The one thing they do have on their, let's say, side is their price point is low, but when you compare it, of course, what we offer from our system, we're in a much better position in terms of what we can offer in terms of performance on the machine. So this is a 40mm by 300, again, a bit bigger than the 25, but likely to come across it in the market. If I go over to Genoptic, so which is the blue one, you're probably aware of these as well, German manufactured system. They do also make a line in China, which is the CS range, which is their entry-level system. Their entry-level system on the CS, they don't have a machine smaller than 50mm. And again, it's a lower spec machine, so I'm not comparing on here because it's not the same apples to apples, let's say. However, their smaller machine on the standard C range they have is a 203. This is a 30mm by 250. Price-wise, they're slightly more expensive than Sylvac Performance. They have a very good specification on their machine, and that's really the benchmark to push past in terms of where we want to have our Scan 25 machine. So we'll look at that shortly. At the moment, the machines have a very good name, and they are performing. In terms of usability and ergonomics, again, we have a strength there above all of our competitors on how easy they are to use, and the ergonomics of the system in terms of clamping and this type of thing on there as well. And we have a lot of added value, such as the tilt axes on there we can have on there. So we'll look at that. Then we have MAR again. We see them as the third player, let's say. If we face Vichy every single time, perhaps we face Genoptic 1 in 3 times, and MAR would be probably 1 in 10 times, in fact. So of course that varies around the world, so it may be slightly different in your region, but that's generally how we see it. They have some traditional machines there. They have a different, actually, they use a matrix camera rather than a line scanning camera like Genoptic and Vichy and us. We use a line scan camera. MAR use a matrix camera, so it's a slightly different take on there, which means a little bit more complex to sort of be dedicated to shafts, but however, that's what they use. And it comes in a reasonable package. You can see there, it's got a full touch screen on there, but when you see them actually programming it on that touch screen, it's when they get to small detail, it's not so easy for them. It's a bit clunky, and they really rely back on the mouse to do things like that. So that's one on there. In terms of performance, we're above them. Specification, price, we're about the same price point, and of course they don't have the additional features such as the tilt axes. So what I'll do is I'll take you through a few tables, and then maybe we can have some questions at the end of the competition if you have any feedback as well to give us. So simple, like football score table, let's say. Football score table here. So if you look, we have on each line, we have the yellow marker on the left side here. So we have the S25. Then we versus the MTLX5, which is from Vichy. You can see I've put down in detail the accuracy for diameter, repeatability, length as well, accuracy and repeatability. I've added a column. You can take it or leave it for the tilt. And then we've got the brand at the end to show you. And where it says sample size, this is saying I've got a 15mm diameter sample size and 100mm length sample size. And that's to give my accuracy specification based on those parts, because obviously there's always a formula attached to the base accuracy on here. So I can see convincingly, and at the end, sorry, in the red. Yep.
Yeah, may I have a question? The last picture, last picture.
This?
Oh, yeah. Yes, my colleague has a question that is between machine C2O and CO3 and Sylvac S25, which one the major pixel more clear? The pixel more clear.
Sorry, I can't. Your sound went a little bit different. You have a comparison against?
Yes, sir. It's mean picture read out is more clear between the between C3 and S25T.
Did you hear that, Jean-Marie?
I mean,
Basaro?
yes.
I think, can you please write your question on the chat? You see, we on the bottom part of the Zoom software, you have the discussion.
Yes.
And you can maybe tip your question. It will be easier for us to understand.
Yeah, the sound connection is not so good. Sorry,
the sound is not really clear. Sorry.
You can type and I'll try to answer afterwards. I'll continue. Maybe we'll answer the question in any way.
Sorry.
Okay, I'll carry on for the moment. Okay, so you can see when we compare our accuracies with the score in the red box, we are winning, let's say 4-0, 3-1, 5-0 against the competition there. So we're in a really nice position with this machine in terms of accuracy and performance. The only one we slightly fall down on is the Genoptic one in terms of repeatability on the diameter. There they have an incredible specification there, but we have a lot of added values to offer on there, which I'll show you in a moment there. So we're in a really good position in terms of performance on this machine, and we shouldn't be afraid to take on the competition. I've done a price comparison again, and this is in euros, so it may change in your market, but this is what we have as a price point on there. So you can see the Sylvac scan positioned list price around 40,000 euros. If I compare that to a Vichy X5, we are more expensive. However, we have a much better machine in terms of performance and value we can add there as well. If I compare against the X10, we're actually in the same price point. Genoptic are slightly more expensive, so we are less expensive there. And Mara is more or less the same. So in terms of price, we are really in a good spot as well when we consider all of the added values we have, all the accuracy specifications and performance we have. We have the tilt axis. So when we're looking at these prices, our machine has a tilt axis, their machine does not. So when we compare this on here, we are really, really in a nice position there. And of course, we have automation ready machines. So we have this robot ready machine, or if you want to put it like that, so a motorized tailstock, additional connectivity options in terms of electronics and pneumatics. So we're really in a nice position there as well. I'll just continue the next couple of slides and I'll come back to the question on the chat, okay? If I compare some technical points, okay, what we have faces what the competitor does or doesn't have. Tilt axis, you can see, well, it's only us. Quick release tooling is only us. Automation ready tooling is only us. Automation ready in terms of IO software air, that is, we're again the only one delivering the machine ready to go like this. The competitors have it as options, but of course they are cost options, so it increases their price more. Same as the motorized tailstock. Okay, there is options from Vichy. Genoptic do not offer an automated machine at this size, so you have to go up to a bigger size machine, and it's a separate line they call the CA series. Part recognition, we have this. Vichy have something they offer similar, which recognizes some features, but it's not the same. Auto measure, so our reflex click mechanism, this is actually patented to us. Vichy have something, let's say, that prompts the operator to do, but it's not the same as our one-click system. In terms of CAD comparison, import, export, that's an offer we all have on there. So you can see, looking at this table at a glance, visually, we've got a very, very nice position. Again, we've got all these extra added values we've got over our competitors, which puts us in an extremely good position in the market. I'll just take a look at the couple of different slides and we'll come back to the chat now. So here's a scenario of a price, and this is, my point here is to compare apples with apples. So really when you're looking at a customer solution, their application is going to define what machine they need to go for. And when you talk about price, don't just take the price from the customer saying, okay, well, this person's cheaper than us or whatever. Understand what they're trying to do, and then really you can understand how to put that to the customer. So if I give a scenario here, this is a customer looking to measure bone screws, and they want to automate the process, and they want to send tooling offsets back to the machine tool. So when you look at our list versus their list on their cheaper one, we are more expensive. But when you start looking at the options and you add the options up from the competitor, when you need a pneumatic tailstock with the connectivity, it's a 3,100 euro from Vichy. From us, it's included. Automation software, again, around 1,500. The software required to do the machine tool feedback, again, the same. When you talk about warranty, perhaps the customer wants an extended warranty. Ours is a standard 2 years. The competitor is only 1. So we have that value again. They sell it, but we have it as standard 2 years. So we're in a much better position when we find the total at the end. Actually, you know, we started off more expensive, but when you add the options up that they would need to meet this requirement, we're on a like for like basis. So we get more bang for our buck with our machines, and our future proofing our machines to be in line with the, you know, the new revolution, to have this IoT system. And when we talk about the application, if it's bone screws, because we have the tilt, in fact, it doesn't really come down to price because the competitor can't do it like we can. We're the only one that can really offer that true measurement on threads there. So this is a good scenario to really understand what the application is. If I was to summarize that in one, let's say, visual, in terms of where we sit price versus combined performance. When I say combined performance, I'm considering the accuracy specifications, the tilt, the ease of use of software, everything we have going for us in terms of automation ready. We're really at the top of the pile there. We have a lot to offer on there, and we have a great performing machine in this Scan 25. And our price, when we look at the horizontal axis across the bottom, we are in line with MAR, let's say. Genoptic are slightly more than us, and Vichy, of course, that's where they play in the market. They like to be a cheaper solution, but in comparison to performance, they are low. So I'm going to look at the chat now. If you want to have a bit of a conversation, you can. So your question, between the C203 and the Scan S25T, which one is more clear for image pixel? Could you send me the answer here? Difficult one to say, because nobody gives this information in terms of pixel sizes and that type of thing on there. So in fact, I don't have a black and white answer on that one. It really comes down to the performance of the machine, because at the end of the day, if I said your pixel was 0.1 and theirs is 0.9 or 0.09, in reality, it's how the machine measures that's critical, not necessarily the pixel size. Of course, it is related, but nobody gives this information. Nobody gives this information. They may say how many pixels it is, but they never give the definition away, the resolution away for any of us. So it's difficult to say. But I'd say the important bit here is really how the machine performs in terms of accuracy. So that's the defining point when the customer says, you know, can you measure this part? You say, yeah, no problem. Here's our accuracy and here's our speed, and this is what we can offer, rather than I've got more pixels or less pixels or smaller pixels or bigger pixels. So it's okay. Hopefully that gives you an answer there. Is there any more questions on competition before we move on?
Please go up to. 他也没有，家也没有，他没，他说很难。但是他是下去。
就是手机相机是底下。
可是我去被他人家去怎么样？确定。那我看他还没有好那个地。
So we'll carry on. If you have a question, please put it on the chat.
Sorry, please go on. Thank you.
Okay, thank you. So I've included here in the competition Keyence, because although it's not, let's say, considered an apple for an apple comparison, because it's really a different type of approach, we do nevertheless see them as a competitor in the market, because they are stronger marketing, they are strong in presenting their product to customers in terms of taking it there and showing them and leaving it there. So they do offer solutions for micro, small cylindrical parts, but it's important to understand what they can do and can't do in comparison to us. So to give you an overview, Akint's is a large field of view system, so it's designed to capture lots of information in one shot. So you could place perhaps multiple parts on their table, and their selling point really is being able to do that, just to throw them on the table. The parts are recognized and they are measured fairly instantly, and they get a result on the screen. However, when you talk about cylindrical parts, which are needed to measure, typically you are talking about thread measurements, and you're talking about dynamic measurements such as roundness, runouts, concentricities, cylindricity, true position on there. When it comes to those features, they cannot do that. Okay, so they don't have a rotary axis, they don't have a tilt axis on there, so they're reliant on only static measurements. Okay, they can measure multiple parts, but they cannot measure, let's say, a threaded part, measure the minor diameter, the root radius, and the cylindricity and everything on there. So they have a limitation of what they can offer, so it's important to know that. They also have limited alignment functions in terms of fixturing as well, because if you place a part on the glass versus holding it correctly and make an alignment, so the parts may tip over. As soon as you have to fixture something on the table, of course, you lose the advantage of just being able to place the parts on there. So if you look at the examples here, thread measurements we can do, they can't. Rotary axis dynamic measurements is a strength for us, they don't really do that. Functionality and alignments requires light adjustment, and of course we are designed specifically for cylindrical parts where they are not. And if I look at an example of what can happen on larger cylindrical parts, if you lay something on the table, it may look good from the top, but actually when you, sorry, the presentation was moved, I don't know why. When you look at the part side on, it's actually tilted over, so they're not measuring the true measurement there. So it's important to understand that. Yes, they're in the market. Yes, the customer knows about them. Our challenge now and your challenge is to make the customers know about our solution, the Sylvac scan for cylindrical parts, and that what we can offer is better measurements, better accuracy, better flexibility in terms of what can be measured on there, and make sure they know about that. Okay, so that's just something I wanted to compare against in the market going forward. Okay. So we'll go through some, let's say, points concerning sales, and to give you a reminder. So benefits we offer to customers. One of the biggest points really when you look at our systems is to reduce time and inspection time. So we hear today, let's say if the customer is using traditional methods, they could be using micrometers, calipers, height gauges, whatever. Of course, we want to sell these, but it takes time. It could take 30 minutes, it could take 2 hours or 3 hours to inspect a part. We can measure those parts in less than a minute. Typically, we're talking 30 seconds. So it's an incredible quick change for the customer. Of course, reducing inspection time also reduces the CNC downtime, and that's the bit that hurts the customer, because if their machine tool is idle and it's not making parts, they're not making money. So we can reduce that inspection time, we can give that functionality directly to the operator on the shop floor. They don't rely on an inspector necessarily, they don't have to take it to an inspection room and wait for their turn to be measured on different systems on here. So that allows us to reduce the investment for control, reduce their scrappage, because we're detecting the scrappage on there. Excuse me, I need to reject a call. Okay, reduce the scrappage, increase inspection frequency, so we can increase inspection frequency to get a higher throughput, improve their process control capabilities, given all the data collection, which makes them more efficient, We get the instant report generated on one machine, which can be shared on SPC platforms or shared on different data platforms there. Used directly on the shop floor. We can avoid the QC bottlenecks by having it used on the shop floor. They're not reliant on another system. No specialist training required. Once you have that product programmed in there, they can just run it on the machine with a simple button. Of course, this ultimately saves costs for the customers, and this is really what the customer wants to hear. They want to save cost, be more efficient, have better quality parts, and give assurance to their customers. So we have a lot to offer on here, and this is an example of really replacing the instruments that may be here today. Of course, we still want to sell those. That's part of our portfolio. But when it comes to sort of more complex turned parts, the time saving, again, we've talked about. So from the scan, you're getting you're getting a fast, reliable, reproducible, and easy to use system directly ready on the shop floor to use, with a full reporting suite there as well. And remember, we can connect instruments to our scan system as well, so we can import the measurements. So if you've got a a bore that needs measuring in there, you can connect the bore micrometer and send the information directly into our measurement report. I don't think you have too many legacy customers in Taiwan. I don't know if you're aware of any, let's say, Taser machines there. Perhaps not, but these are ideal customers to approach because we can just flip them directly into a new machine, give them a faster, easier to use, more accurate machine, and take over any of their old programs. Another one to look out for is, let's say, traditional technology, such as optical comparators. If you see these on the shop floor in your customers, it means they have the application. It means they're already measuring cylindrical parts, and we can replace those or complement those with a Sylvac scan, giving a better, more accurate, more comprehensive measurement solution for those parts. So something to consider when you're walking around customers. To remind you what sales tools we have, and this is always changing. We always like to add, and hopefully we'll have more things coming around the corner. We have the sales flyer, the 2-page flyer. We have the information we released with the machine. We have presentations we can give you. I think you'll have this one. We can obviously offer you more presentations if you need. Just ask Jean-Marie or I. You have the software, so the demo software you can show on there as well. You'll have the demo machine, which is fantastic, and thank you for that investment in us. That's a great way to obviously show it, is to show the machine itself. Videos are available online. We have the investment calculator if you need it as well. If you need anything done remotely, a demonstration, some training, parts to be measured, we are always here to help you. Jean-Marie, it's okay to go in this one? The pricing?
Yeah.
Software, okay.
You can go ahead.
So to the end of April, we have the free upgrade to pro level software. So this gives you the CAD, the monitoring, the scripting, everything. So that's a free software upgrade to customers who want to purchase before the end of April. We can offer that. You can have an upgrade to pro or offline. And we're also offering on the big machines a 10% discount on your net price there. So that's an incentive you can share with the end user to help make some sales, and they're available to the end of April. Any questions on the pricing, obviously just ask Jean-Marie. So just a reminder of some sales points and strengths we have. So we have the tilt system. It's a huge one when we're looking at threads. Of course, we have Swiss-made quality machines there from Sylvac. Easy to use software with the part recognition, the one-click measurements on here. The touch panel on the front, which is a nice new interface, making it even easier. Quick scanning functionality there for really rapid measurements. We have the quick release tooling, motorized cell stock automation ready system, class lead in performance, and of course we can offer all the other additional requirements such as the instruments we offer, indicators, calipers, micrometers, etc. So that's something we can add on there. We have a 2-year warranty as standard. We do offer up to 5 years extendable warranties. If you have any questions on that, then please ask Jean-Marie and we can discuss that with you in a bit more detail if you are interested in that. but obviously that gives peace of mind to the customer. Having that 2-year warranty off the bat from the factory is a good point to have. I'm just going to give you a little insight into the future in case you were curious, and then we can have a look at the machine. So this is our timeline in terms of the development roadmap, where we've come from. So 2017, we introduced the first sort of Sylvac scan from designed 100% upwards, let's say, from us. So the S60 range. Then 2019, we introduced the big machines, the S145, and now obviously we are releasing the S25T. In the future, we will replace the Scan 52 as an entry-level system. That will be at least 2022, sometime thereafter, perhaps, we'll see. We are analysing now to see if the cost saving without the tilt axes warrants having another model of machine. So basically, if it saves enough money and we can have a lower price point without a tilt system for those companies that don't need the tilt axes, we will look to introduce that. So we'll give you more information in the coming weeks about that one. And then hopefully by the end of this year, we'll have some detail to share with you concerning the probe measuring system on the scan machine. So we will introduce this on the 145 machine in the first instance, and this will be a full probe system here to make 3-dimensional measurements on the scan, and also to measure blind features that aren't visible with the optics, such as slots, holes, face runouts, which are hidden by different features as well. So that's an exciting new venture there that we're going to introduce, and again, we'll hopefully be able to share more information as the time comes on that. Any questions on what you've seen about future products or anything else? Good.
Hi. We said we will send the question sent to.
You want to send the question? Okay.
I mail to.
Yeah, sorry, yeah, okay, you type
We will
question.
Will send options to Mary by email.
Okay, yeah, that's fine. Yeah, we'll take care of them. Yeah, we can't hear you very well, so yeah, if you can message or email, no problem. Happy to respond to you.
Thank you.
Okay, so what we will do now is we will look at the machine itself. Okay, so no more presentation. We'll look at the machine on the video, and then I'll show you some of the software features as well. So we'll have a look on there. Of course, this is the idea of this training, is to give you an introduction, to give you a bit more information, to highlight some points we'd like to highlight, to enable you to discuss with customers more confidently and have that information. It's not the end of the road. We're always here to help you. So if you receive your machine in a few weeks, of course, we'll do the service training. But if you need to revisit and you have some questions on how to run the software, you have some applications, let's say, then just let Jean-Marie know, and we can arrange some more training remotely to help you manage the software or manage the customer applications. Okay, so this is just part of the process. Okay, it's one step in here, but we're always here to help. And of course, without travel, it's difficult to visit you, but maybe one day in the future we'll be over in your facility and visiting customers together. I hope so anyway.
In 4 or 5 years we will be able to come to Taiwan.
Yeah, maybe. Okay, so for this part, what I'm going to do, I'm just going to stop sharing the video of me. You don't need to see me anymore, and you'll see the video of the machine itself. And what you need to do is just make that a pin. Okay, so if you add a pin to that video, and then you can just focus on this one itself. And I just stopped sharing my video so it's focused on there, okay?
Thank you. Nice.
So I know you can see the machine, but you can't see the screen so well, but I will change view on the camera and I will focus on that when I'm talking about that as well, okay? So I'll give you an overview of the machine. The machine is sat, currently I have it sat on a stand. Okay, at the moment we don't offer a stand, but we will do shortly. We're just going through the process of designing that. So you can see I've got it on a higher stand, which is about 1.1 meters up off the ground because I want to use it in a standing position. Just give you a view around the machine so you can see it's nice and compact there. See the ventilation. I've got an articulated arm with the screen and the keyboard and whatever else. And just around the other side, you can see the PC at the back. The top of the machine is just a black top there, and nice looking machine, really good quality and feel about it as well, which is what we want to see obviously from a Swiss made machine. And I'll take you through the operation of the tailstock in a moment because that's an important point, but I'll just focus in on the tooling and I'll show you the tooling itself there. Hopefully that's detailed enough. It's in a nice position. Okay, so here you can see the ISO adapter. So I've got a standard center in there, which comes with the machine with the coating on here. And this silver portion here is the ISO adapter. And to extract that, all I do is push down on the collar and I pull it out. So very quickly, I've just released that there. And you can see this portion is the adapter. And then inside the bit I'm holding on and the center here is actually the Morse taper center. And to put it back in, I just do the reverse and I push that back into the holder itself on there, which is nice and easy. It's exactly the same. If I look up at the tailstock, okay, you can see that it's the same tooling, and I'll show you that in a moment. Anyway, on the front of the machine, this is where we have the access, if you can get in there, to the pneumatics. So the pneumatics are only used if you want to have a pneumatic fixture on there, such as a grip or a chuck or whatever. So you can see there a little bit what's going on. Okay, I'll just replace that on there. So I'll just come back out now. Oops. Okay, so we'll have a little bit more of a look at the functionality of the machine on here. So you can see the tailstock is at the top. This is spring loaded, so I can push this up and down, okay, on a spring itself. So if I want to load a component which is already positioned, I can do so just by pushing in a part or lifting up here on the ISO tooling or the fixture here itself. Now to control the tailstock position, okay, change view. So I have a slider on here. So as soon as I touch the screen, you'll see the lighting actually changes color to say I'm active. If I want to move it, I just pull down a slider, and I'll zoom into the screen in a moment. I pull down the slider. If I move it down more, it goes faster. If I let go, it stops. Okay, and also in the reverse, obviously, I can go up to the top and down. Now, because I've got a part loaded in here, and I'll show you how we go through that in a moment, what I can do is load the part between the centers. It's got a predefined position in the program, so it means I can just place the part in there. I can hit the arrow at the bottom. It goes down quickly to a pre-position. Then it goes in slowly and clamps the part. That's the part clamped. Okay, so for my recalling of a part program, you can see the part's clamped nice and easy. If I want to remove that, I can just say unclamp, okay, and I can put the next part in, for example, and then just say clamp on the component, and they'll be there fixed in there. So that's how to use it through the control panel. Or again, as I said, you can just remove it on the spring release. And of course, if you want to chuck and whatever else, you don't need to necessarily consider this on here. So let me zoom in onto the touch panel a bit closer, and then you'll be able to see that on there. Hopefully it'll be a bit clearer. Okay, so I think you can see the panel more or less. Zoom in a little bit more, there we go. Okay, so the panel you see on there, so it's a touch panel. It's actually a Raspberry PC, which mimics, or not mimics, but it's connected to the main applications to change the modes. And as I said before in the presentation, the idea of this is to be an interface for the operator to manage the component itself on there. So I'll show you here, let's say a program loading. So you've got the different modes at the top. On the left, you've got the reflex click. So you can just simply touch on it. That will give you the part recognition and the loading force there. So if I just show you how on the touch panel, how that would work, and I'll just load a component in. I know you can't see the component at the moment, but here we go. So when I'm loading in for the first time, so I'll move my tailstock down. You can see it's got a force manager here. So I've put my part in. Maybe I'll just tie. So you can see I've got the part loaded. Okay, let's just go back there. Okay, you've got the part loaded, and I can see here I can increase the force. So you can see this dial here is telling me the force I've got on there, so I can increase or decrease that according to my clamp. So that's the first time I make a measurement. So I'm just going to take here, so you can see the control of the tailstock here. We have the, let's say, move up to extreme limit top. We have unclamp. We have the slider here, and then we have the clamp arrow. So I'm going to hit the top one, just I want to release my part completely. And I'm going to select a part program. So I could do the part recognition, but I'll just show you how we reload the component. So I've gone into the replay mode. That's activated my open program, so I can hit the open program. And here I've got a selection of programs I can go through. So I've got an arrow down the bottom, or I can swipe as well if I want to, depending on your preference. So I can move across to the part program I'm interested in. I can double tap on it to open it up, or I can select like this and just say open. That's my part program open now. So once you're on there, now I can clamp the part as you saw before. It just drives down. So I'm going to place the part in. I'm going to hit the arrow at the bottom. That's just driven down to a clearance point. I'm now clamping the part, and you'll see as we clamp, it clamps to a predefined force. Okay, once I'm loaded, just move around a little bit. Once I'm loaded in there, I'll just hit the nice big start button, and that will go ahead and measure the part. And I'll show you the machine scanning in a moment when I've just gone through the results. So the part's measured. Here are my results. Nice and quick, obviously. This gives me a summary of the results. So I get a full results on the screen if I need to, but generally operators only need to see a pass and fail and see really the highlighted points on here. So this is a list of the measured points. I can scroll down and you can see I've got the label, the actual and the deviation, and whereabouts I am in my tolerance band here. I can scroll down the different pages by simply selecting the arrows. Okay. If I want to replay or I want to load another part, I can press the play button here. I have the print function, which will print out a nice template. I have the classification here, go, no go for the entire part, which is also on the LED, and I'll show you that in a moment. And then at the top here, I have some filters. So I've got filter for the pass, filter for fail. So if I want to look at just the failed features, I select that, and that highlights those 2 failed features. So as an operator, it's really quick just to go, okay, what's wrong here? Let me have a look, and it will show that on there, what feature that is to be seen. Okay, so you can unclick it, and I can just filter the pass ones, or I can unfilter completely. And that's the nice results there. As you said, you can print from there as well. You'll see some information at the top. In fact, there's a light bulb. I can turn the light on and off, and I'll show you that shortly. Temperature, settings, and then I can go to the home position, and I'm back to the home window there. So what I do is I'll just pan out and I'll do the same thing more or less, so you can see the machine actually scanning as well. So I've got the part program loaded. Okay. Sorry. Part program loaded. I'll just hit the play button, and you'll see, if I come in, you'll see the part being scanned. So you can see the green line scanning. You can see the optics there going up. Parts measured. The LED changes, and then I get the results obviously on the screen. Let me just do that one more time. Okay, so you'll see the green light here, scan the part, goes up. So this is the optics we're looking at here. And this here is a protective curtain. okay, to protect the lights on there. You can see the LED on the screen as well. So that's giving you a nice clear LED on there, and you can turn that to just an illumination mode if you're loading the parts as well. You can just turn it on and off if you want to see the classification or not. Okay, so that's the, let's say, the main points: the fixturing, the loading, the control of the tailstock, scanning of the component on here. Perhaps I'll just show you why we're in this position here. I'll load up a different part program. I think it's this one, yeah. Okay, so you'll see the part being scanned and rotated on there as well. Okay, if you have any questions, again, you can send them on email after or the chat. I'm just going to share my screen now again, and we'll look at some software features as well. Okay, hopefully you've got the idea of the touch panel, the control of the tailstock and everything, and a nice view of the machine. You'll be very impressed when you receive yours. I'm sure you won't be disappointed. It's a really nicely packaged machine, good quality machine, and very accurate as well. So what I'll do here is I'm just going to use the main interface. I'm going to open up a part program and just run it once. So we'll talk about the statistics side of things, so the monitoring, the data monitoring software we have now. So you'll see on this program, I've got this enabled to use the monitoring software. At the bottom of the screen, you'll see I've got an additional tab. Okay, additional tab here is data monitoring. So I've got this part program, you can see here loaded, demo, gold demo static. And inside I've got all the characteristics of that measured part. Okay, so you've got the different views here, different characteristics I can select at the top, and it's just like Silcom. There's no difference really if you're familiar with this on Silcom. So I've got the evolution chart, I've got the distribution curve, I've got the full view if you want, I've got the basic go no go if you need to, and of course at the bottom you're seeing how many parts I've measured, the mean, the upper, the lower, the CP/CPK, the variance, etc., and the range. And there's a table of results as well you can see with all the information you may want to see on there, like who measured it, etc., batch numbers if you've got it enabled, nominals and so on. So you can obviously export this information as you would do in Silcom. You can see at the top you've got the CSV export, the statistics in Excel. So obviously historically anywhere we had data stats analysis on the scan machines, although not like this. So we still got the ability to export to third parties or just as a CSV file in parallel with this on here as well. There's different filters you can filter by. For example, I can look between different date ranges, how many, the last 50 I've measured or not. So I could maybe turn that one off and then go from a certain date if I wanted to. Okay. So we'll just have that on there. That's okay, Valentine's Day. Filters. So we can have here the different filters if I want to filter by part number, trace fields, operator, that type of thing. All the things you're used to. You can minimize this screen as well if you want to have different views of it and have different templates, bring it in there. And I can drag and drop this into a secondary screen if I wanted to as well. So that's nice and easy. To enable this in the program itself, okay, I just go to the settings menu and I go to program report and export, and I simply tick this box here, and that enables the particular program we got loaded to send out the data into the monitoring software. So that's nice and easy to do, and of course you've got all the information you expect to see in here. Okay, hopefully that's fairly self-explanatory. Now what I'll do now is I'll show you the thread wizard, because I think that's an interesting point. And as I mentioned, of course, if you have the need and you need to have some additional training, please feel free to say, and we can make the arrangements for that on there. So the first thing I want to do on here is I want to actually load the component. I'm just going to take this part out. And what I'll do here is I'll load in an actual bone screw to show you how we would work on here. going to grab that sample. Okay, so we have a bone screw, which I'm going to load in the machine, and we'll take a scan of that, and we'll show you the new thread wizard. So I just need to bring the I'll start down. This one's a little bit easier just to do it sideways. Okay, so we've got the part in. I'm going to go into my composer. So hopefully there's some of you that are familiar with this from training you've had in the past, perhaps at Sylvac. So I'm just going to scan this part in now. Okay, nice and quick. We've got to scan. We'll see the data on the screen. So here is an image of the thread on the bone screw. You can see what it looks like. Now, this is before we've tilted the optics. So the first thing I'll do here is I'll actually just create some date and positions that we would do on a standard program. And I'll make a quick alignment. Okay, so there's my thread alignment. And I'll just do a secondary edge. So now I've got that on there. What I want to do is create another scan of the component. But this time I'm going to tilt the optics to make the scan. I'm going to add that as a secondary layer. So I've come up to the scanner, pushed the little arrow. I've typed in tilt 10 degrees, and now I'm going to say add layer. This will tilt over, scan that part at 10 degrees, and you'll see now when I zoom in, you can see the difference between the green layer and the black layer. The green one is the tilted one, the one we want to see. So that you can see that easily reveals these corner radii and the flank, the true flank. So you can see I've got one steep and one more shallow angle and a different root radii. I've actually got two different root radii from left to right. And that's what I'm going to show you how to program now. So I'm just going to remove, set this one as a default, just so it makes it easier to see for us. And just remove that one. So now we've only got the tilted axis on there. Now to make this thread measurement then, I come down to my thread feature. It's called Thread Wizard. So if you need to turn any of these on, you just come to the settings menu, select the features, and you just simply scroll down to the one you're interested in, and you click on the box to turn it on, and then you can click on the box of the sub features to turn those on as well. So I'm going to come back in here, Thread Wizard. I'm going to make a zone I'm interested in. So that's selected the area I want to measure, and this opens up the interface. So at the top, I select what type of thread it is. In this case, it's parallel. What does it look like? What does the shape look like? So the idea now is to pick the one that most suits the profile, the one we're looking at. In this case, it's actually what we call a buttress. So I've got like a leaning thread. If you've got one steep and one shallow thread there. I then tick what options I've got. Yes, I want to measure with tilt. I'm going to scan in a static mode, so I won't rotate the part in this case. I'm going to pick the standard buttress option here. I hit the arrow. This takes me into the interface here. At the top, it gives me the overall view, so I can see where I am looking. On the bottom right, it highlights those thread forms. So you're actually seeing all of the thread forms average here because they're over the top of each other. And you can see the sub features of the zones. That allows me to control the zones. Now on here, I'm just going to pick my references at the top, tell it what tilt angle I should be. And then I'm going to control this. So I'm going to say, okay, I want my zone to be a little bit lower on the top, and bring this one down and across. This one's about right, but we'll just pull it again off that radius and maybe a little bit there. Okay, so I'm happy with my zone. So this is detailing the sub features. This is something which was not possible with the standard thread feature, because we always knew what we were expecting on that one, so we didn't need to care about that. Because it's custom, I've got a different flank to left and right, I've got different root radii, etc. So what I'm going to do now is I've got the outliers filter turned on. I've told it it's a right hand. These numbers are related to the box. On the left hand side here at the bottom, you can see a list of features I've got available: major, minor, pitch diameter, etc. We can turn on and off the features we're interested in. I'll just show you as we go through there. You can see it's highlighting on the top drawing where we are. Now, one of them is the root radius. So I'm interested in that. So I'm going to turn that one on. But you'll see the default is actually showing me the zone at the bottom, because that's where you would see it on a standard thread. Or actually, I don't want it on there. I'm going to move it, and I'm going to add one. So I'm going to create a left root radius. So I'm going to bring this across to here. Okay, so I'm changing my zone on this one, and that will show me at the top a highlighted version of that. Okay, what I'm going to do now is add another root radius. So you've got a list of features here that you could add on there. So lots of different options on here, which we won't go into today. But here I want to add a thread root radius. So I've just clicked one. I turn it on this one, I call it right. And now I can change my zones on here to bring it up. Once I'm happy with that, I can save that as a template. So let's call it EB Forever Bright. I tick that and I hit my finish flag. Once I hit my finish flag, I've now got that thread programmed. I can enter my nominal sizes for this in here as well. As you see, as standard nominal, lower limit, upper limit, etc. I've got everything else to measure on here. Once that's done, I can measure that part with that template I've created. So you'll see the machine scan. It will scan the part first to do an alignment, and then it will tilt the optics and rescan the thread profile and measure those features I've just enabled on there. So now I've done that in one. I've not had to position the part, care about it. I've got my major, my minor, my pitch. You can see my different flank angles. You can see my root radii. If I zoom in onto the machine, you'll see there's a lot of data there. Nice high definition point there. You can see lots of points in there as well, creating that measurement, which is perfect. And if I want to measure that thread in the future, providing it's the same shape profile, okay, even if it's a different size, I just come into my thread wizard, select my templates. You can see here I've got one called EB. I have that, I place it on, I set my references up. The right hand side, as if you would do anyway. And there I have a nice, ready to go bone screw measurement from a template I've created. So nice and easy, nice and quick. It gives me all the functionality you may want to have on there. Okay, there's probably some questions on that maybe, but you've obviously got the video to go back to if you wish. And that kind of brings me to the end really of presentation. So if you have any questions, now is the time to ask. Or you can send an email, of course, or in the chat. Jean-Marie, anything you would like to add before we finish?
Yes, I don't know. Do you want to have some time to discuss together, or and get back to us, or you will discuss together and send us your question by email? It's maybe easier for us to understand and to answer clearly, because the line is not that good. So I think we can, for yourself, is it over, Dwayne?
Yeah, I'm finished now. Finished. I've showed the additional thread features. Unless there's anything they would like to see now, I can repeat or view.
Yeah.
For them.
Actually, of course, today you have received a lot of information.
Yeah.
It's something new for you, so it's not easy to catch everything. And of course, when you will have physically the machine at Everbright, you will be able to make some trial by yourself. And as Dwayne said, we can, of course, arrange some more training sessions with more practical example as soon as the machine arrive in Taipei. So as I drop the message here on Zoom, your machine should be delivered by mid of April. Probably by April 20, you should have the machine in Taiwan. So once you have the machine, again, we can organize one more training if you want us to help you to practice with the machine. And of course, I was joking before with the date of my next visit, but of course, we hope to be able to visit you before my retirement. So let's by the end of this year, I hope to be able to come to Taiwan, of course. So thank you very much, Doan, to have prepared this very nice training.